for Algebra 3. Lesson 69 deals with matrices and determinants. You should already be familiar with matrices. We're not going to spend a lot of time there, right? If I ask, I mean, most of us we're familiar with how to set up matrices in our calculators, correct? How to solve those things, what an element is, how to do the dimensions. It's rows by columns, those types of things, correct? So we're not going to spend a lot of time there. In fact, really, even the next part of this, which is dealing with determinants, is even fairly easy to do. If we go to our graphing calculator and we set up a matrix and we wanted to know what the determinant was, we would go into second matrix, we'd go over to math, and we'd hit the determinant after we had put everything in our matrix, right? And we could hit enter and it would tell us what the determinant was. Now, some of the determinants that we get, or some of the matrices that we get, aren't just a list of numbers. If you look at questions 1 and 2 here, obviously you couldn't put that into a matrix and get a determinant for it. Okay? So when dealing with a 2x2 matrix, if we want to find the determinant of it, I'm guessing, this is stuff that was covered either in Algebra 2 or Geometry or both. So if I have A, B, C, and D, and I wanted to find the determinant of that, I would take A times D minus C times B. Right? So basically you're multiplying down, then you're subtracting and multiplying across. Okay? So as we look at question number 1, what I'm doing is I'm saying x minus 12 times x minus 2 times negative 16. All right, and we're going to say that that equals 5 out over here. We're going to use that to solve for x. So far, does this make sense? All right, so x minus 12 times x, that's x squared minus 12x. We've got essentially negative 2 times negative 16, right? So that's 2 times 16, which should be, what, 32? So we're going to say plus 32 equals 5. Of course, now what we're looking at is a quadratic equation. What do we want to do with the 5? Subtract it, bring it across. So we've got x squared minus 12x. What's 32 minus 5? 27. Okay, so plus 27 equals 0. Then we would factor that down. Okay. Things that multiply to be 27, we got negative 12 in there, so it really should be a minus minus, right? Do you concur? Okay, do we understand why it's minus minus? Yeah. Okay, good. All right, so get a little bit more communication in here. Things that multiply to be 27, well, that's not a real long list. That's probably, what, 3 and 9? Right, and it doesn't matter which goes where because they're both that. So I could be x equals 3 or 9. The next part of this, let's see, let me look through here. And yeah, we can have more than one answer in this. I think even whenever I did this in my page, I actually went through the whole quadratic formula, that negative b plus or minus, and that's really not necessary, right? This one factors down fairly easily. So 3 or 9 for that. Okay? Does that make sense? All right. So because I feel like this is easy enough for you guys to be able to do, what I'm going to do is I'm going to leave this up here on the board. I'm going to hit pause on the video, and I want you guys to solve number 2 on your own. Yes. All right, so the answer that you should have gotten on number 2 is D, negative 9 and negative 8. And one of the reasons that this works out is because a determinant is essentially an absolute value. So our answer should equal a positive number. If we put in negative 9, if you put in negative 8, you're going to get a positive 9 in one of those and a negative 9 in the other whenever you plug it in for x. And of course, it's absolute value, so it's going to come out as positive 9 in both cases. So real good job there. Let's see. You just have to make sure that whenever you get it down to x plus 9 times x plus 8, that you go ahead and you solve for x in those instances. All right, in 3 and 4, that's bringing us over to lesson 70. And we've touched on this information up to this point. Do you remember when we were talking about standard deviation, where we had a standard normal, or the mean of distribution, sorry, mean of distribution looked like, had this middle number, and then I had 3 standard deviations to the right, 3 standard deviations to the left. I had 68, I had 95, I had 99, right? Went essentially like that. Okay, so this is that same type of information, and then I think we even discussed how to find a z-score, and a z-score is essentially this. It's how many standard deviations a number is away from the norm of distribution, right? Do we remember how to find that? We took our number, we subtracted the mean, and we divided by our standard deviation, right? And that gave us how many standard deviations we were away. Well, we're going to use that to actually find that z-score. And z-scores can be, well, if you look over page 442, the table below, if you look at that, gives the decimal fraction of the scores below a given z-score. So what you want to see, and I can't pull this up, well, I could, give me a second here. I'll try to explain what a z-score table, how we read it. If I can get an example pulled up. Internet may be really slow today, I don't know. Okay, they're going to, okay. So a z-score table, after we get that, that z-score, right, let's say it was, let's say you got 0.6, okay, 0.6. It's not just 0.6. So for instance, let's come down so we see like a positive, because you have to look down the left and the top. It might be easier to look in your book, because we can get positive and negative, meaning that whether we're on the left, negative, or right of our standard distribution, or our mean of distribution. All right, so down the left, all right, we've got 0. So 0.00 is going to be this 0.5000, right, which we can convert that over to a percentage. So we're basically taking that standard deviation and converting it back into a specific percentage. Because the only thing that our little chart is going to tell us, we can break it down into a couple of different things, but we can't get super specific with it until we have a z-score, and that z-score can be converted over to a percentage using a decimal. So if I had, you know, let's see, 1.401, okay, that would be 92.07%. Does that make sense? Okay. All right. So if you do not already, you should have a post-it note on page 442 of your textbook. Okay, so if you have your textbook here with you today, check that. If you don't have a post-it note, okay, let me get you one. The reason why is because, you know, in later homework assignments, you're going to need that table, and so you're going to need to be able to refer back to it to know what those numbers are going to be. Okay. Okay. So let's go back to our notes. Okay. So let's look at question number 3. It says the duration of routine operations in a certain hospital has approximately a normal distribution with an average of 166 minutes, a standard deviation of 15 minutes. Approximately what percentage of operations last less than 175 minutes? Use the standard normal table. Okay. So what we're going to do here for number 3, because we want to know, you know, how many are less than 175 minutes, we're going to take our number, 175, that's the number that we're using, and we're looking for the z-score. We're going to subtract the mean of or the average of distribution, which is what? We're looking at question number 3. 166. We're going to divide by the standard deviation, which is what? 15. Okay, so we're going to plug that in our calculators, and we should get a decimal value. Okay, 175 minus 166 divided by 15. 0.6, right? That 0.6 is important. Okay, now we're looking for the percentage to that. So let's bring it up here just so I don't want your stuff. All right. 0.6. No, because we got 0.01. Let's just look in our book. All right, so you can find 0 down the left-hand side, right? Okay, now you're going to look across the top and find 0.6. You guys see that in your book? Okay, now you're going to look at the number where they cross. Okay, what is the decimal at which they cross? 0.7257. If you'll notice, this is a problem in this particular chart because it's 0.01. We needed 0.6, right? So it's not getting big enough in that respect. So let's see, let's come back here. So we're saying that the z-score, okay, comes out to, we said 0.7257. We're going to take that, and it's really not too hard, convert that to a percentage, so move our decimal point 2 places to the right, and we get 72.57%. Does that make sense? Okay. So, our answer is what percentage of the operations last less than 175 minutes? Okay, 72.57%. What does get tricky, I don't think that they're going to try to trick you on this lesson yet. They'll get into more advanced types of questions of this, where we're looking at 175 and we're asking how many are more than 175 minutes. Because if you look, the mean of distribution is 166. So if we're looking at this, we're saying, oh, well, 166 is here. The standard deviation is 15. So let's go ahead and see how that works. What's 166 plus 15? What's that? 181. Okay. So less than, so our 175 is in here somewhere, right? So we're looking at what percentage falls to the left of that. Okay. But, rather than trying to just kind of brute force figure that out, this formula actually works out a lot faster for us. Now, if we were looking for what percentage was greater than, right, that's going to be a little different, right? Okay. All right. Let's see. So the next one should work out really similar. The duration of routine operations in a certain hospital. Okay, you can see normal distribution average of 178, standard deviation of 5. What percentage of operations last less than 182 minutes? All right. So help me set this question up. Let's see. Vanessa, can you help me set up our equation? We want to take the number that we're using, right? We want to use that number first, all right? Let's see. I'm trying to be more specific in my wording here. We're going to take the number that we're trying to find the difference from. Notice that they tell me that that the mean of distribution is 178, right? So let's kind of go. I'm going to put back on the board our formula, which is the number that they're asking about minus the mean divided by standard deviation, right? Do you have this down somewhere? Yeah. Okay, so I'm going to erase this. All right. What number are they asking about? There you go, 182. Okay. What is my mean of distribution? 178. And what is my standard deviation? 5. So we want 182 minus 178 divided by 5. 0.8, right? 0.8. Now, the mistake that I think a lot of people will end up making is skipping the z-score and taking this straight to a percent and saying, oh, well, that's 80%, right? In this particular case, it's not far off of that, but it's not that, okay? So we need to go to our chart. We're going to find 0 down the left-hand side, and we need to find 0.8 across the top, okay? Where does that cross at? 0.7881. Okay, 0.7881, which as a percent is, there you go. All right, so it's really not that hard, right? Remember your formula, get your decimal, go back to your chart, run those two numbers across, and then convert that to a percentage. Okay, we feel pretty good about that? All right.
Is this lesson, is it like a double lesson, like, are we doing it from two different lesson sets?
No, if you look in the instructions, it should be just be from lesson 70.
Okay, can I use it real fast?
I'll have to go through and look, but you might wind up with more because I'm going to end up saying, okay, 1 through 5 in 69 plus questions, and 1 through 5 in 70 plus questions. But we'll look at that. I'm going to hit stop for now.